Hello everybody and welcome back. We're going to continue on studying the 2012 Canadian Senior paper in this video. We're almost done part A, which is just the final answer style questions. We're going to be looking at question number 6 today, and it's quite a question. Let's take a look. So hopefully you've given this question a chance before you watch this video. But either way, let's crack on. Lynn is tiling her long and narrow rectangular front hall. The hall is 2 tiles wide and 13 tiles long. She's going to use exactly 11 black tiles and exactly 15 white tiles. So 2 times 13, we need 26 tiles, 11 plus 15, so that's enough tiles. Determine the number of distinct ways of tiling the hall so that no 2 black tiles are adjacent. And by adjacency, they mean cannot share an edge. Okay, so what does her front hall at least look like? We can get ourselves sort of a vague picture. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that's 13. And we have a line running all the way down the... Oh, that's awful. Oh well. So this is basically what her front hall looks like. And we want some of these tiles to be black and some of them to be white. In total, we need 15 white tiles and 11 black tiles. So we can't have the black tiles share an edge. So immediately what that tells me is no column, so 2 tiles, looks like black tile, black tile. That's impossible. So each column has, at most, one black tile. So these are our possible arrangements of tiles in a single column. Black then white, white then black, or white and white. So, each black tile gets its own column. We have 11 black tiles and 13 columns. Alright, so each black tile gets a column. We have 11 black tiles. That accounts for 11 columns. But there's 2 columns left over. They're going to be only white tiles. That's why we have more white tiles than black tiles. If we had 13 black tiles, we'd have 13 white tiles, and each white and black tile would have their own column. And then at that point, we just sort of be alternating. Do we start with the top square black, and then the bottom one's going to have to be black, and then black, and then black? But these white-only columns are interesting. There's so few white-only columns, which I'll probably eventually just call white columns. that we might ask, where do they go? Where can they fit in? And there's lots of different locations that we could probably put them. And between them, we're going to have sort of sequences of black tiles with a top tile black and then the bottom tile in the next column black and so on. So it's really the white tiles that will dictate where everything can go. Once you have a black tile set, you know what the black tile, where the black tile in the next column is going to be. So we can have both of them together at one end. There's two ways to do this. We're going to have so the two ways are they could be at the left end, so both these columns could be white, or both these columns could be white at the right end. We can have them both together somewhere in the middle. How many ways are to do that? We have to treat them as a single unit, so they can go here, 2, 3, 4, 5, 6, 7, 8, 9, 10 different ways to do that. Okay. Or they could be separated. One at each end, there's one way to do that. So we could have them be separate and have exactly one of them at an end. How many ways can we do that? Well, we have two choices of the end. These columns of only white tiles, they're indistinguishable. But we can have, there's two ways to choose what end. And so if we chose this end, we can't have them together, so the other white tile can't go here. It can't go at the other end, that's another case altogether. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different ways. Okay. And finally, we can have them separate with neither at an end. Okay, so maybe the first one is in this fourth column and the next one is in this sixth column. So how many ways are there to do that? Well, we're choosing out of these 11 columns, we need to choose 2 of them. But then we also need to ignore the cases where they're side by side. How many ways are there to do that? So there's 11, choose 2, which I think is 55. Then how many ways are there for them to be together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Minus 10. What's 11 choose 2? So that's 11 times 10 divided by 2 times 1. So that is 55. Subtract off 10, we should get 45 ways. Okay. So these are the places that the white columns can go that are distinct. We haven't counted any different way of the white columns behaving. We haven't counted anything twice. But you might be wondering, okay, why did you separate them this way? Okay, I could have done a little bit of experimentation ahead of time to justify why I separated them this way. I do apologize for that, but the idea came to me already, and I sort of hinted at it, and I'll explain it right now. So other than these white columns, every other column is going to have at least one black tile in it. Well, if I have a white column here, came from this way, we have a white column, and I know I have a white column over here. I can fill in this space exactly two ways. Either we have a black tile up here, and then a white tile, and then a black tile down here. Or a black tile could be first placed down here at the bottom. But once our first black tile is placed, it determines the rest of the group. Okay, so once we have our different ways of figuring out where the white tiles are, we just need to count up how many of these groups of black tiles we have. And each one of them, there's two different ways to lay out the tiles. With the first black tile from the left being at the top, or the first black tile from the left being at the bottom of its column. Okay, two ways to do each black group. So, spacing the white tiles out the way we did, the way we listed the different ways, it was based on how many black groups we're going to have. So overall, we had white tiles being together at an end. There were two ways to do that. And there's one black group, so two ways to put the white tiles there and two ways to tile the black group. Gives us a total of 4 ways. Now, if they're together, but they're somewhere in the middle, that means that on either side of this block of this 2x2 block of white tiles, on either side we have a black group. So that gives us 2 groups of black tiles. Each of them has 2 different ways to be tiled. Let's just double check how many ways were there to get the white tiles in the middle. 10 ways. Okay, so that's 10 times 2 for each black group, so 2 to the 2. So there's 40 ways to tile this situation. They're separate and they have one at each end. That gives us one black group. That's 1 times 2 equals 2 ways. So in total we have 46 ways so far. Okay, what were the other two scenarios? So one at an end, another in the middle. That gives us 2 black groups. How many ways were there to do that? Well, that was 20, and then 2 times for each different black group. So that's going to be 80 ways. So now we're up to 126 different ways. And our final situation, with both white tiles separate, but they're both in the middle. Right? There's neither at an end. And that gives us a total of 3 black groups. So that was 45 different ways just to get the white columns in position. And then each of the 3 black groups, there's 2 different ways to tile it. So we're going to do 45 times 8. Which is 360 ways. So we have, 40, I think it's 4 plus 40. Plus 2, plus 80, plus 360, equals 486 ways to tile the hall. Okay, so we just need to put our final answer of 486 in. It was quite a question. It really relied on combinatorics and noticing that the all-white columns are what's special here, and it's separating the groups of columns that have a single black tile in each column. And those ones don't really contribute a whole lot. They're just sort of alternating. So there's 2 ways to do that. So the big thing was, what are the positions of the white tiles and how many black groups do they give? And that's about it for the question. But some serious combinatorics going on there. But we've made it. We finished off part A, so now we're going to have to start thinking and justifying and writing out full solutions for the B part. But that's for another day. So thank you all for joining me, and I'll see you guys next time.